What's happening, everybody? So here we are talking about evaluating trigonometric limits by rewriting the function using identities. And we are at the bottom of page 49 for this example. And it says to consider trying to evaluate this limit. So if I do that, and you have to give me a second with my marker tool here. If I try to evaluate this limit, I'm going to get something that looks like this. I'm going to have the limit as theta approaches 0 of 1 minus cosine of 0 over sine squared of 0. Well, up top we're going to have 1 minus 1, and on the bottom we're going to have straight up 0. So we've got 0 over 0. So undeterminate form or indeterminate form, and we got to figure something else out. So that's always the first step, and now it doesn't mean that the limit doesn't exist. We got to try rewriting it. So we got to go back in our brain cells, and hopefully you guys did some of this in the past, but you got to go back to the knowledge of trigonometric identities. So there was one that looked like this. And notice my squareds are in two different spots. It doesn't matter, it means the same thing. That's the Pythagorean identity. And that's a trigonometric identity. So obviously, because it says the freaking word in it. Great. I'm shy at this point. I don't know if you can tell, but I'm doing my best, y'all. So we can rewrite that any number of ways. And if you look over here, you got sine squared. Well, what does sine squared equal? Let's find out. Sine squared of theta equals 1 minus cosine squared of theta. Well, maybe that's going to be helpful. So let's scratch all this. This didn't work out, right? That's not what we want. So let's try again. We have the limit as theta approaches 0 of 1 minus cosine theta on top. And on the bottom we have sine squared theta, but we're now going to replace that with 1 minus cosine squared theta. So you got to go back to your factoring knowledge here. So if you remember something like x squared minus 1, how to factor that. You can do x plus 1, x minus 1, right? But you got the same kind of thing here, but it's a little bit backwards. It's 1 minus cosine squared, right? So what we can do is we can factor out that bottom component. Limit as theta approaches 0 of 1 minus cosine theta over 1 minus cosine theta times 1 plus cosine theta. So that's a perfect square binomial. Okay? That's not right. That's, what's it called? Difference of squares binomial. Excuse me. Difference of squares. Because you got one square here and one square here, or one square here and another square here. So now that we have that factored, that's good. Let's see, we can cross these out. So what do we got? We got the limit as theta approaches 0 of 1 over 1 plus cosine of theta. Cool. Well, now let's see if it works. We plug in 0 now. What's cosine of 0? It's 1. So now we can go ahead and get our answer. 1 over 1 plus cosine of 0 equals 1 over 1 plus 1, which equals 1/2. And we have found our limit. Wonderful. So now, I want to scroll down here, hopefully. Let's see. Oh, and we're on the next page. So this should be page 50 in your notes, the top 3 examples. And we're going to do the same type of deal. So let's see what we can come up with. Let me get a pretty color first. Ooh. Ooh. Okay, now we're ready. So we plug in 3 pi over 2, tangent of 3 pi over 2, that ends up down in the vertically south position on the unit circle. So the tangent is going to be 0. Cosine of 3 pi over 2 Actually, tangent's going to be undefined, excuse me. So plugging it in right away, we're going to get undefined when we try to take the tangent of 3 pi over 2. So, how can we rewrite this thing? Let's check it out. Limit as theta approaches 3 pi over 2. Well, what do you know about tangent? You know tangent is sine over cosine. So let's rewrite that. 3 sine over cosine of theta times cosine theta. So we have rewritten our problem. And we got some nice stuff already happening. We've got the cosines canceling out. So we've got now limit as theta approaches 3 pi over 2 of 3 sine theta. So once we rewrite it, we want to try and plug it in again. So what's sine of 3 pi over 2? Well, that's the vertically south position on the unit circle. So that's going to be what? -1. So we now know what this equals. It is 3 times the sine of 3 pi over 2, which is 3 times -1, which hopefully is -3. Cool. Next one, secant. I don't know what you did last year. I need some water. Hold on. So I got my water and I'm better. So secant, I don't know if you remember from last year. Secant is the reciprocal trig function for cosine. So secant can be rewritten as 1 over cosine. So let's check it out and see if that helps us at all. So we have the limit as theta approaches pi over 2 of 1 over cosine theta times cosine theta. It already looks wonderful to me, over 4 theta. The cosines up top will then cancel, creating a 1 in the numerator, and now we've got a nice little limit expression that we can evaluate. We have the limit as theta approaches pi over 2 of 1 over 4 theta. And now we can plug that in, and we will get equals 1 over 4 times pi over 2, which is the same as 1 over 2 pi. And that is our limit. Beautiful. And then the last one, same sort of idea. You plug in pi right away, you get the sign of pi on the bottom. That's going to be an issue. I didn't talk about it here, but obviously here you're going to have the same issue when you try to plug in pi over 2 right here. You're going to have 1 divided by 0, because the cosine of pi over 2 is 0. So if we plug in pi here, sine of pi is 0, we can't divide by 0, so let's try and rewrite. Limit as theta approaches pi of, what can we do? We can rewrite tangent again. Cosine of theta times sine of theta over cosine of theta, and all that is over sine of theta. Beautiful. Cosines cancel, rewrite. Limit as theta approaches pi of sine over sine. Not much to do there, y'all. What happens with the sine over sine? Becomes 1. Beautiful. Isn't that wonderful? And there is your limit. Well, that's all I got for you today. I'm beat, so I'm gonna head out, and I will catch y'all next time. Pass the couch, y'all.